option. Okay, so what we're going to do today is we are going to look into a little bit more on your adapters. These are components that you can add onto your systems, right? Many of you are familiar with gaming system, and probably the most expensive thing on most gaming system is your video card, right? GPU is highly demanded right now because of because of your AI. LM requires that you have the processing power to be able to execute a lot of the logic in how it would make the decision for artificial intelligence. And then because it's working with a large data set, you typically would see that GPU or video adapter is demanded, right? But in the video adapter, you also have storage, memory. So that's really important to think about when you buy your video adapter is how much internal storage it has. Also the capability for connectivity on how you can adapt it to the system, right? We want something that's versatile. So most of the time you see a new video card that's going to have a display. So all of these systems that you see, the Alienware that you're sitting in front of, they are using display port, which is an L-shape connector. Okay. All right. So let's go through and do the assignment together. So I want to always go through the ports because the majority of the issue will come from power, right? And how you connect to your display. So if I have a display like a monitor, and if I'm not using the right cable, right, or if it's not connected properly, should be still or something, then I don't have success in the connection. Someone emailed me about the water bottle. Did you find it? Oh, please. Was it there? Yeah. Okay. Okay, good. Say a question? Oh, you want this. Okay. So VGA is the first one on the left. As you can see that it is typically, yeah. Typically it's the blue connector on the left there, right? Sometimes it's also in black. And when I say it's a female, that means that it has holes that you can connect. The cable would have pins, so the cable would have the pins, and that's how you would be able to connect to it. One second. Today I seem like I can't multitask too well. And then on the second port, which we are very familiar with, you have the HDMI. And we talked about that, right? It's the high definition multimedia interface. So for certifications and for future reference, we want to be able to know what the acronym stands for.
How long is the certification?
90 minutes, 90 questions, a minute a question. And you have to pass it with 80%. Seems like Office 365 is also like, maybe it's their SharePoint. I'm not even connecting to their SharePoint. Okay, so I have the assignment for you. And then on the next port, this is more of an older port. This is a DVI-I. And the DVI-I came after the VGA. But I think VGA was very common for the old television and monitor. So typically you would see the DVI-I, right? It's either black or sometimes it would be white like this. So your DVI was another option that you can connect. Now, if you go out and buy a video adapter today, like I said, you typically would have two or one HDMI, and then you would have maybe a couple display port for sure. Okay. And then if you ever play the old Super Nintendo, right, or Nintendo system, you would know about S-Video. So I think Super Nintendo came out and S-Video was apparent because before that it was the analog cable. So if you and whenever that you see video connections that has the red cable, the yellow cable, and it looks like the old headphones cable, a little larger, right? Those are analog cable. And the difference between analog and digital signal is that analog signal is in waves, right? It's not consistent, whereas digital signal is zero and ones, okay? It's either on or off. So everything that we use today is digitized from the communication. So even your wireless signal is in wave, but your system convert that, right? It encapsulates that and convert it into digital signal. So in your text, so let's say that I record my text in voice, right? I'm going to tell my family member to remember to cook dinner, for example. It is an analog signal, but your phone takes that and convert that data into zero and ones. And so when it sends that text through the network, your mobile network, it is zero and ones. But when it gets to the destination, the other person's phone, it converts it back into an analog wave. So that's how you're able to hear. And instantaneously, you hear people. And if there is a lag, it's very small, it's very minute. And we see this with like video streaming, everything that we use, right? So if you watched a TikTok video or whatnot, it's still when it was created, right, before it got added to the system, it is in an analog format.
DVI, what stands for?
For the DVI, give me a second. Let me give you the information. So on your, where is my stuff? Oh, maybe I didn't grab it. Yeah, I have the notes. And so I think it's digital video interface for the DVI, and then the I is actually the pin. This particular, if you look, there's like 4 holes here. There's another one that you would see that it is actually only 2 holes on the side. So the pin sizes are different. Okay. So I have the assignment on here. I have to grab the lab bit. Yeah, they need to fix the problem with you guys' login. This cannot be happening but maybe in the future we can drop files as you log in. Okay. Sorry for the delay. All right. So the typical type of HDMI is that is going to give you, now we see this is only like 1K, right? The 1080 is your typical pixel size for most monitor. Here, I was trying to use my laptop connecting to projection, and I asked the IT team here, the multimedia people, that why is it flickering, right? They were saying that it was my video driver, the software that controls my video card on my laptop. But what happens is that some projection system can only handle display at a certain pixel size. So just like what we were talking about yesterday, if you have fancy equipment and you're trying to project 2 systems trying to negotiate, right, how it's going to be able to consolidate and display, sometimes there's differences in the configuration of one system to the next system, right? It causes issues. So the typical version is going to be 1.4B, but I think it's been upgraded to a better standard. Okay. All right, so let's do the next one. So let's look at the HDMI. And yesterday I told you about there's different type of HDMI. You all have to plug it into a PC. Your laptop doesn't have Word that way. Yeah, unless you log into your portal, which have my Office 365, and you use the computer in class. You can use the guest account. Yeah, when you log in, there's a guest option. You can use that. It will allow you to edit files and save, but not very much in changing settings.
You change it from the Office 365 to Microsoft 365 now.
Right, which is still the same. It's just the workspace is a little. It's like how Google now have a workspace, right? But it still have docs and sheets and everything else. Just another label to their product with additional features. So the second one here, this is called a Type C, just like how you have USB, right? So not a lot of people know about like the different variation in HDMI because we're most familiar with the HDMI, but if you look closely on the picture, there are holes in it. You never notice? So these are female connector. So whenever you see that there's holes in them, right, they are female connector. And so that means that your television or your monitor, right, the connector point is a male. So it needs to adapt to that. So the second one is a mini. And if you look at the size, it's flatter, it's slightly smaller, right? And then on the Type B, this is what you see on the Raspberry Pi 5, right? I think the 4B and the 5 came with a micro. The reason why is that on the Raspberry Pi, it's tiny. I'll bring it in tomorrow. I typically sometimes also teach a class with Raspberry Pi, but HDMI Type D is known as a micro. And if you look, it's smaller. It looks similar to a USB, but if you see, it's a little bit wider, right? And the connector, if you look at the pins, it's different. So the rule in hardware is that if it doesn't fit, don't force it, right? So it's really made for exact pin numbers and size. So if you trying to plug it in and if it doesn't fit, that means it's not supposed to be connecting.
Which one is best suited for cell phones?
So these are typically not equipped with smartphones. These are for display. So if you might have a tablet that comes with it, very rarely, but typically it's for computer or video adapter. For your phone, it's USB, right? You guys know what USB stands for? The chicken foot? Yeah, universal serial bus. So a serial signal is 1 bit at a time. Did you know that? So it's kind of like if I'm gathering water in a bucket and I turn on my faucet, I'm doing 1 drop at a time. That's what a serial is, right? It's 1 bit at a time. But what it is that they group up the bits and to be able to transmit it through the wire. So ultimately, if you're looking at USB, is it really fast? Not necessarily, right? So if you compare that to other type of standards or cable, like HDMI or whatnot, right? Because USB-C, a lot of the cable for USB-C that's able to use for display, not all of them can be used for display. C is also classified for connection, charging, for data sync, charging, and display, right? But HDMI is specifically for video and sound, high definition multimedia interface, right? Okay, so let's look at the display port. So it's an upside down L shape, and there are 2 types of display port. Typically, you would see a gaming computer or a video adapter that's high end, or VR comes with a display connection. And the first one is your most common one, and that's your standard DisplayPort connector. So display port is able to give you faster rate compared to the HDMI. So if you have an option to connect your TV or your monitor with a display or a HDMI, connect it with the display because you are going to have better throughput, especially if you're gaming. Now, some system will come with the mini display port connector. And when you look at this, it is a little bit higher than your regular, like the micro USB, but you would see that it is slightly bigger. Bless you. And typically you would see that it is gold plated. The reason why that they use more precious metal in computing is because of oxidation. Did you know that if you recycle your computer, they melt down the metal and resell it for precious metal? Because a lot of the silver, copper, and gold goes into your computer components, right? To do the traces on the boards and also like parts of chipset components and so on. So now if you get a HDMI cable, which I have here, right? So mine has a gold plated, so that way if I touch it with my oily finger, right, it doesn't get oxidized over time. On the ones that are not gold plated, you tend to see that sometimes it can be rust if you live in like a place that's very humid like Florida. So that's the only difference in the grade of cable and also how they classify as the class. But most of your cable that's sold is class in the United States is classified with a certain standard. So my husband a couple years ago he went to China and he went to a technology mall, right? And in that mall you can buy everything technology. And so he brought back like a bunch of HDMI cable, and when I was using it, I realized that it is a different standard, so it doesn't adapt too well, right? So you're going to see that they do sell different standard other parts of the world because that's what they use. So what you want is you probably want the latest standard for your system or compatible standard. Are we clear with this? Any question? So now you know how to connect your monitor. This is kind of what you were talking about here. So this picture was taken from an Apple system. I wanted to kind of look at the old Apple and see what kind of USB that it has, right? Apple doesn't have USB ports anymore, especially on the Air or the books that you buy or even the Macs, right? So anytime that we see a rectangular shape with a chicken foot, we know it's a USB and that's a type A. And this is a 2. Okay, USB 2. And then the later integration for Apple was that they agreed to implement their C USB. Okay, so USB, but they call it Thunderbolt 3. Now, if you look at the old Thunderbolt cable and ports, it's actually transmit faster than some of the USB in the market. And that's what really made Apple stand out with the data sync. I heard, right, I read through my feed that they are releasing another type of cable and connection in their system. So that way, they can keep up with, the demand in data sync from external devices into their system. Okay, so you should ask, how many USB can I connect, right? And so I always ask my student, how many devices can you connect to your wireless router, right? Most people don't have hundreds of devices to connect. If you do, that's a pretty intense household. I think most of the time, at most we're at 20, 30 if you use a lot of smart devices. But remember that everything comes back to one source. Okay, so if you're using a hub, you probably would have to connect many hubs to connect this many devices. So what do I say a hub? I saw you using a hub yesterday. It's an adapter that you can connect many USB to it, right? So what happens is it's like you have 3 lanes of cars, and then you detour them into one lane, right? And so Well, when that happens, what happens? Slows down because of traffic. The logic is the same in the computer. So what happens is you are going to be driving the lane for these devices. You have 127 car. You're going to narrow it down to your hub, which probably is going to consolidate and bring in your data based on the path that it's built. So the speed that it's built. So the maximum is the magic number is 127 devices. But as you add more, you're gonna see that it gets slower. Okay. And sometimes not even recognizing the devices because those hubs tend to not do well with like multiple connections or identifying generic USB.
Why 127 instead of 126?
Yeah, so it's possible that your hub, right, your Apple systems, right, needs to recognize the whatever that's connecting to the hub. Two things is happening. You have file systems that are from PC trying to go over to Apple. So it's kind of like two people speaking two different languages, and none of them are acknowledging what the others is saying, right? So you have two different file systems, and but we would your USB should have a standard file system, which is the FAT file system that's acceptable for all OSs. However, when I save my file, it's in a Word application, and if you don't have the application, it doesn't do that. But also the hub also doesn't get recognized by it because it's standardized possibly. So maybe return it and then check to see if there's devices that's sold that's good for Apple, right? Okay, let's do the next one. When you leave this class, you're gonna know USB for sure. Okay? Because I always have challenges with technicians. They're like telling me that they're using a certain cable, but that's not the right cable, right? So it's really good to have the proper terminology. And so if you say that you know what you're doing, right, and you get the job and you go there and you tell them the wrong term, that's embarrassing, right? So we want to make sure we know all the devices and the connections. So from here on out, and whenever that you shop or you upgrade your system, you would know. Okay, so from the left to the right, we talked about this yesterday. Okay, so the first one is your C. It's oval shape and it's flat. Now I put 3.1. You don't have to put 3.1. The industry just recognizes as USB 3, right? It could be 3.5 by now, 3.4. It's just USB 3. And on the cable itself, sometimes they color code it, sometimes they don't. It depends on the manufacturer, right? But if you look at the shape, we talked about the oval shape for the C, and the C transmit faster. It's a higher rate. The next one is your type A, and this is what you see with your printer cable and your USB that you're using for storage. When it's blue, we know the third one is a type A, but it's a USB 3. The difference between the 2 and the 3 is that the 3 is faster, and you would see the color code. They intend the color code to specify the different standard. So who does all of these standards, right? If some of you probably know, it's IEEE. IEEE standardized a lot of the electronic equipments and communication systems. Some of these systems and cables are tested, and if they go through testing, that just means that they qualify and it's met the standard, right? But they don't always go through the testing. Testing costs more. And then the next one, we talked about this yesterday. Number 4 is your micro. This is a 2.0 or USB 2. And then the one next to it, you see. So this one is very popular with external hard drive, and I'll show you. It looks like a V shape. So the common external hard drive these days, right, comes in USB-C. But not all computers have USB-C. Most computers will have USB-A. So you're going to have one end, right? One end that looks like a V shape like that. And like the number 5, and that's a micro B. So if you have an A on one end, the B is on the other end. Except for the C is the oval shape, right? That's the newest one. So if you buy an external hard drive for $50, these are like a terabyte. Your BN goes to the drive, right? And your AN goes to the computer. And typically it is like that. So the B is going to be for the device, right? And the A is for the computer because most computers have the A connection. Okay. So will I connect this to the computer, the B? No, right? Only C. If you have a C cable, sometimes you would have a drive that has a C connection and your computer has a C, which it does. You can use C on both ends. Okay, we talked about the mini yesterday, or I'm sorry, we were at 6. Mini B, right? It has a little groove. It's a little bit higher compared to the micro. This is a little bit older. So I think some of the old Android and older system uses the mini B. And then when you look at the printer USB, they are a little bit different. So printer cable tend to be like gray or blue, and they're USB cables. So one end you're gonna have an A, and the other end you're also gonna have a B. Okay, so you're gonna have a 2 and a 3 for the USB. The difference between the 2 and the 3 also is the color code and the size. So the 3, as you can see, it's a little bit higher and thicker. So, and that means that your printer is fairly new if it's using the 3.0. I think most of them now comes either wireless or the 3. They give you a cable, so that way in case you need to physically connect to print, you can. So my question for you is, if you have a wireless printer and you have a cable, which one do you choose? Do I choose it to connect to my wireless network to print? Or do I choose it to connect to my local system with a cable? Which one's better?
Wireless.
Wireless.
Yeah.
And I hear some cable in. So why is the wireless better?
I can print from my cell phone.
So yeah, so wireless, so your router is like, it's like a star, right? It's the center of your star. That's a star topology. Everything connects to the router. Your phone connects to your router. Your laptop connects to your router. So you can print it from anywhere. That's the plus side, right? Why the cable?
More protection.
More protection, but it's only for that system, right? You might, and that's kind of true. So if I connect to that computer, I can only print from that computer. I don't turn on the wireless option. And so I minimize the risk from other people connecting to the wireless. But your wireless devices, you have to know that when you turn it on, it always tells the other. That's what the systems is designed to do. I'm here. Look at me. Connect. Let's connect, right? And the same thing with Bluetooth. If you ever turn on your Bluetooth, it's looking for other Bluetooth devices, right? So, yes.
We continue. Yesterday talked about the using the wireless printer.
Uh-huh.
Not very safe.
Mhm.
My question for you, can I take the cable and my printer, hook it to the router?
Sure. So but it defeats the purpose of being wireless if you're using a cable and if you hook it to the router. The router is designed to be a shared path for everybody. It's kind of like a center where all the devices meet, right? All the devices communicate. So if you are connecting it to the router anyways, you can use it with the wireless. Now, an option for you is when you go to a workplace, they're gonna have a print server. They have print servers here too, right? So what a print server does is it's a dedicated computer that's connected or control all the printers. They do that for schools because they can control what you print and how you print and they see your print. Okay. If you go to like places like that have copiers, like Staples and things like that, they are connecting to the system, and likely that they are going to have a server that is managing those devices. So what you can do is you can schedule print, and it's really easy to set up a print server. You can just have your computer, your PC, running, and then you connect to that printer, and then you configure it as a print server. That means that everybody prints has to go to that system, right? It is a control system to the printer. And so the reason why we do that is you can cancel people print, you can control paper usage, you can control power resources, right? Like I can maybe turn it on low power option if my printer has that, which what you see with a lot of the large copier. If you ever surface large copier, they are computer. They have drives, motherboard, everything inside. Rico is a company in Orange County. They always hire technicians to be able to do that. And you'll be surprised how many companies still use printer, copier, or even the printer with the roll and the little dot on the side, right? If you ever go to car dealership or anywhere that you have to sign for a loan or lease, they typically give you a carbon copy to sign, right? Those are specialized printer. I service those printer from like the 90s all the way, and you see that still today. That's crazy, right? Okay. So today you're gonna see another cable, right? SATA cable, serial ATA, is used for hard drive. Okay, this is the way that we can connect hard drive inside the computer, our storage. The eSATA is for external hard drive, and this is a little bit more rare. So comparing eSATA to my USB micro B, right? Which one do you think is faster? You can also ask AI, but AI is going to give me the same answer that I know, right? So on certification, you have to know the rate of your data transfer, right? For different type and different standard. That's why A+ is kind of hard. So serial ATA is really designed for data transfer with drive. So it's obvious that it is faster. Now, if you compare that to some of the later USB like C, right, it stands up. But it's really designed for data storage, right? Like write file, save it into the drive, and take it from the drive and read the file. Okay. So these drives, if you get like the Western Digital, Toshiba, if they're like 50, 60 bucks, and for external hard drive, they are hybrid drive. They're not solid state. That means that they are still components that are hard drive enclosed in a case that's externally used, right? But if you get a solid state drive, they tend to be smaller because it's basically a chip, right? Or a card, and it's enclosed in the space. I think I have it. I can show it to you also in the back. We bought some of them. And then you have the IDE, which is like a flat ribbon, and these are gray. If you look at the notes, it's going to show you the picture. And then there's SCSI. So it's crazy. I was looking at something the other day, and SCSI, we call that SCSI. And SCSI been around since the 80s, right? Before some of you were even born. And the way that they use SCSI is that they would chain them together. So when I chain them, it's like having Christmas lights at your home, right? You buy 4 strands of light and you want to wrap it around your tree or your house, right? You don't just do one strand and then connect another. You're going to connect them together, right? To be a long strand. And then you're going to start wrapping your house. So the way SCSI works is that you interconnect them. So if I have drive 1, right, I'm going to connect drive 2 to drive 1, drive 3 to drive 2, and this is how server, or what we call mainframe, works back in the day. And then at the end, the last drive, let's say number 8, we call also daisy chain. So sometimes there's chain into one. So like I would have drive 1 and then 2, 3, 4, 5, like a daisy, like the flower. It would chain all back to that main drive, right? And then on the last drive, you would have a terminator. So on it, you would have this little notch and you turn it on. and it ends because it doesn't relay the data to the other drives. Okay. So it's a way that we can connect many drives together. Now, the problem with that is that sometimes one drive fail and everything else fail, right? Because it's like if you don't have power source to one strand of your Christmas light, nothing else turns on, right? So that's the same, okay? But I was reading the feed and it tells me that there's like current technology that uses SCSI. And SCSI was like really fast for its day, right? And you look at it now, you're like, huh, it's not as fast as some of my flash drive, but that's, I mean, our servers were really slow back in the day too. But that's still a buzz term for some of the connection these days.
So we're for the number 10.
Mhm.
Have we done that already?
Not yet. We're going to do that now. Similar. So we talked about this yesterday, right? Upgrading RAM for a computer, but we talked about like the size of the RAM. So if the client requests RAM upgrade, what's the important information that you need to bring? So when you did the lab yesterday, what did I tell you? Right? We need to look at the memory type, like PC2, PC3, PC4. PC4 stands for DDR4. PC5 is DDR5. And that is really the type of RAM, right? But it really reflects the speed of that type of RAM. So it's kind of like you buy a sport car and it has a V8, right? Which is a big motor, or you buy a compact car that's a V4, 4-cylinder, right? If you compare which one goes faster, of course the one with the bigger engine is gonna go faster. So when you have a DDR5, right, exponentially, it is faster compared to the 4. Okay. So when you see PC4, PC3, PC2, some of them label it like that, then that means it's DDR. Okay. And so we're going to identify. So you need to know the type, the form factor. So when I say form factor, it really comes down to, but it's also like the DDR is where the notch. So you can't mix them up. I cannot install a 4 into a 5 system, okay? Because they're different size in the pin. They made it that way so people don't make the mistakes. And without RAM, your computer will beep and will not turn on. Or it might not even beep, it doesn't turn on. Because RAM is required to boot. Any type of OS, it needs RAM. Okay. All right. We talked about the speed already, which is what you saw with the number, right? 2400, 3600, that's your frequency or hertz rate. And then capacity, we saw this yesterday, 512 megabyte, tiny, that's half of a gig. Okay, your USB drive is 16 gigs, so exponentially bigger. And then motherboard information. So because everything connects to the motherboard, so we want to make sure it fits. And then existing adapters. Anything that's next to it. So I have students that are like, oh, I bought this kind of RAM. If you ever look at gaming system RAM, right? They come with a cover. Everything matches the motherboard. Because I go to the makerspace in my office and they're always showing me, oh, I built this system. Dr. Lynn, come and check it out. And everything, they got like, the color, the glowing cases, everything is white or everything is black. I'll bring you in one of the gaming system that I bought at the end of COVID. Maybe tomorrow I'll push it in here. So you can see I let it the club that I advised, they built it so you can take a look at it. It's pretty clean, it's not bad. But it was an i5 that I got. Like I think 9th generation i5. So the RAM sometimes is very thick and it might not even fit, right? So you got to consider like where it's going to fit on the motherboard, and also the look. I think gaming system people care for how it looks. It's kind of like if you buy a sport car, might as well get what you want, right? If you want convertible, if you want the color or leather interior, whatever. Okay, let's go through and do these RAMs together. Okay. So this is also typical for A+ certification. They want you to know So we're gonna start with the earliest, okay? There's a little circle to show you the differences, but the 1 and the 2 are very close. So the first type of DDR was the first one, number 1, right? When you look, it is slightly longer on the left. That's correct. Remember, when you put it on the slot and it doesn't fit, it's not supposed to go there. But if you don't know, look at the motherboard information. All motherboards manufacturer, they have it on their website, like what kind of RAM should go there. If you buy a motherboard, it would also tell you, right, in the box, or also, through the specification. And then on the second one, this is a DDR2. So double data rate is what DDR stands for. So if we say double data rate 2, so it's multiplier of 2. Understand? So that's quadruple, right? So if let's assume that if I transfer at 8 megabyte per second, right? If I double that, that means it's 16. But if I quadruple that, that's 32, right? So exponentially, when you go up a level, it increments. But if you study computer science, Moore's law will tell you that there's a time that memory rate, read and writing is going to plateau, right? So when I teach advanced Python, we talk about that, because when we write program to get the processor to do things simultaneously, remember what I talk about, like having 4 children, make them wash the dishes at the same time is faster than having 1 to do it, right? So we can have 4 core doing the work, but when they do the work, you have to have internal cache to handle it in the processor. But based on Moore's law, right, you can only exceed, and this is what you see with processor speed. Right now, we're at the cusp of like 4 to 5 gigahertz, right? We will see if they can break through in the design to be above that, right? So because there's physics and other things that are involved, what you see is that there is a max, a limit to what you can design in the speed. Yeah.
Is quantum computing gonna help with that? Is that what it is?
Yeah, a lot of it. So right now the AI pushes the quantum chip, right? And quantum is tremendously faster. But how accessible is quantum, right? So a few years ago, there are only a few companies that have quantum, and even today, right?
Yeah.
So you can have a handful of company. So right now, AI processor, you're gonna have NVIDIA and some of the companies that do, twin technology, that is NVIDIA, right? They are redesigning the chip, but instead of using quantum, they're redesigning the chip to be able to handle tasks a little bit different. Yeah, I attended AI infrastructure last year, and they were talking about like networking system, like switches and routers, and how some of these chips are going into these communication devices. Because if you want ChatGPT to give you things immediately, you gotta get fast processor to give you the network connection.
Yeah, like thousands of NVIDIA chips.
Yeah, but it's weird. It's just like a tweak in the equation using linear algebra. Like there's not complex math, because a lot of people are like, oh, is it like some crazy equation? But when they showed it, and I was like amazed, and how they solved the problem, and the engineers they showed it. So there are a lot of companies now is doing the push in how they use that for calculation in the processing. And you're gonna see that in memory as well. Okay. And then on the as you can see on the 3, right? As you move to the 3, the left got longer here. So the notch is a little bit different. So that means the pin size on the left is more, right? So when you install, just make sure that that little cutout or the notch match up, okay? And then when you push the RAM in today, when you do the lab, the lever automatically closes, okay? It's really designed, it's a pressure base. So the old school system is that you have to kind of latch it. So this little notch is on the side. There's 2 arms that's holding it. You saw some of this today with the little RAM in the laptop. So on the 4, as you can see, the 4 is almost like back like the 2. Okay, so they move it back. But all of these are for your storage.
The what?
For your storage. These chips.
Well, the one at the bottom has
The-
more capacity than the one on top.
Yes. And also faster.
Yes.
And as we go, we want more capacity, right? Everybody now, most people. So I talked to one of the students. He was like, yeah, I'm shopping for a gaming system. And I think I'm going to go like 64 gig plus. And I was like, what are you going to do with 64 gig? That's a lot. I mean, you're going to do heavy gaming, but 32, like the system that you're sitting at is 32 gig, which is plenty. But yeah, as we, use a lot of simulation and a lot of like display that requires it, your application requires RAM for sure, right? If you're running heavy apps, then you need it, like virtual reality, stuff like that. Okay, so the difference between DDR3 and DDR4, major things that change, and you see this with DDR4 into DDR5, which is DDR5 is the one in the current market, is that they transition it to reduce the power usage. They increase the pins, right? Which allows them to improve the speed. And so your computer uses the crystal oscillation for clock rate. So you want RAM chip to actually synchronize with the processor. So the processor is the brain, like imagine that's your brain, right? But if your brain is thinking 100 miles per hour, you need to, like, let's say that you need to do work. Okay, you need to be able to write a paper and your brain is moving very fast. You want your hands, your eyes, and everything else to type out the paper kind of almost the same, right? To really be efficient. So in a computer system, the input-output clock rate is very important because the components that is used for thinking must be close to the speed. Understand? So will it ever match processing speed? Not necessarily, but equivalent or close enough is what is ideal. Are we achieving that? So on some higher end SRAM, you see some of that. So your processor has internal storage, and that's truly for buffer for temporary. So it's kind of like, I'm folding clothes, right? But instead of putting it into my closet, I put it in my basket. So the basket is like the buffer for the processor. It's temporarily putting it there, and then eventually it's gonna move it into the closet, which is your RAM or your drive, right? That's how it works.
But you have to have that computer slow to put the running.
Yeah. So on the new Apple systems now, right? I'm sure that you probably read what happens to RAM. So they passed the law because there's a push for the people to upgrade Apple computers. Like, I want to buy more RAM for my computer. I don't want to buy another computer. So they passed the law. So Apple has to agree that, oh, you can add more components to it. And guess what happens? They came back and they released another model. Everything is soldered in. How are you going to do that? You have to unsolder it. Are you an engineer? Electrical, right? Soldering is easy, but if you unsolder it, you might break it. And then, so people take less risks. And so they ended up not upgrading ultimately, right? That's a way to, just like how on the Android tablet that you used to be able to have micro SD that you can, insert so you can save more things. And they did away with it. So now what you do, you buy a phone or a tablet that has more internal storage. You have to, right? Because you need it.
What happened to the cloud?
You can have cloud, but your system stores things locally, just like what I said, puts it in the basket, and then eventually it's going to move it to the closet. So the cloud is your closet. If you don't have it in the basket, it's not going to move, right? You can't just take whatever and throw it in your closet. You have to, there's like a middleman that handles that, right? Or I shouldn't say middleman, but middle location. Okay. All right. So when you buy memory, there's two things that you need to look at. One is parity, and ECC stands for error correction code. Not all memory card or chip would have these, right? So you pay for what you get. Sometimes you would buy memory that's very cheap. It's not even tested or rated, right? So back in my days, we used to go to computer show, and then we would find things, parts that are really cheap, and we'd throw it into the computer and it works, right? Sometimes it doesn't work and you can't have a refund because it's like a swap meet for computer parts. And but now if you buy it online, it's very clear. If you go on Amazon, you say, I'm looking for RAM for my computer, it will tell you if it says parity and ECC. These are technology that is giving you more accuracy and consistency. Okay, so that's kind of like insurance for your memory. Okay, but you pay for it. So ECC is an error correction code. So in the case that your data for your app goes into the RAM and it's wrong, like a 1 is a 0, what it does is it checks it. And the way it checks it is just odd and even number. Okay. Your computer is really simple, and I teach assembly, low instruction, right? It adds everything. Imagine that. You're like, wait, it's giving me games and it's letting me connect to the internet, but everything is calculated out to 0 and 1s, and it sums things up. So even on a negative number, it adds a negative number, right, to subtract. When you divide, you subtract many times. When you multiply, you add many times. So how does it correct the data? Let's say that your data combined is odd bits, right, like the 5 bits. It checks that and it says, wait, it's missing a bit. There's only 4. It's an even number. So it's going to replace it with the last one, which is a 1. Right? 5. 1, 2, 3, 4, 5. If it's missing 1, right, it's going to add the bit. But if it has an extra bit, it takes it away. So it does an odd and even check. Okay. So I'm just summing it up, but like when you teach operating system for computer science and engineering, you kind of have to dive a little bit deeper. But that's kind of like cliff notes to that. So you kind of get what I mean, right? So it's just correcting the bits that way. And then it also does the parity. It checks the transmission of the parity in the bits where it's stored. So error correction code is good. Okay. Anytime you see that in the storage, that's a plus for your storage. It does that for drives too. Okay. All right. Optical discs. You saw yesterday systems have optical discs. So these are long gone. I remember when I was teaching this type of class, the first time I taught computer repair was to electrician because they had to learn how to work and fix some of the computer components when they service electrical systems. And, I was talking about optical drives, and it was very popular back in the day, CD burner, DVD burner, and then I was like, yeah, it's going to become obsolete one day. It is definitely obsolete today. So CD is low capacity, right? And it has the longest wavelength, and it uses a laser. If you have a CD player in your car, like my car, I have a Honda. I never really use my CD player. I stream most of my music anyway. But if you have an old CD player, if you hit a speed bump, it skips, right? Because your laser head possibly is unstable, or your CD is not good, or it's not clean, etc. So there's a lot of different factor that goes into that. But it does have the longest wavelength, and it has low capacity. That means that you cannot store a lot of data on it. So if you're looking at songs on a CD, you're gonna be limited to, like, depending on the size of the songs, at the most like 16, 18 tracks, and so on. DVD came out. This was mostly for movie space because it has higher capacity. So when you're looking at a movie size, it's a lot larger than what you see with music, right? MP4 compared to MP3, that's compression format. MP4 is definitely bigger in size. So that's why DVD came out. It uses shorter wavelength and it uses red laser, where CD uses green laser. You know what else uses laser? Your fiber optic, right? That's a light source. That's why. And laser is pretty consistent signal. It's one of the better signal that we typically use in technology. And then Blu-ray came out because we have bigger movies, right? That has the highest capacity in optical disc system. But you're like, so if you're my parents or even my era, you heard of a laser disc, right? So imagine it's like a record, but laser read, right? Instead of the needle moving back and forth and reading it. That was short-lived anyways. So Blu-ray has the highest capacity. It also uses short wavelength and it uses blue laser. So now you know the difference. When you see the CD, DVD, Blu-ray, when you fix system that has it. If you look at your, yeah, these have it too. Did they remove it? Yeah, some of the models actually.
That's what
Yeah. So, you know, some system will still be equipped with it. I think we bought these like 7-8 years ago, so they came out, but now most of them are gone. Okay. You might have player at home, right? Just like VHS, eventually they're gonna become hot commodity because if you buying even a boombox, a tape player these days is kind of harder to find, right? Because people don't produce them anymore. Okay, so I'm gonna go through these optical drives real quick, but for super multi DVD drives, this is for like burner. So when we say burner, it's a drive that you can store, you can write data to the disk, and you can also read from the disk. Like I can play movie and I can copy the movie, right? So is it illegal to duplicate a movie that you bought? Let's say that I really, really love that movie and I want to make a copy of it. Is it illegal? You guys know copyright rule? So you can have a, yes, did you?
Wants to say no, is you're not redistributing it.
Yes, that's correct.
Okay.
So if you have a backup copy of it, it's legal. But if you take that copy and you put it online and you share that folder to a bunch of your friends, and then they make copy of it, then it becomes a violation, right? So if you ever plan to work for government agency, Department of Defense, FBI, CIA, anybody that does clearance, right? Be careful about illegal stuff digitally. They know because they know your IP and they will find out. I've had like CIA agents come and talk to my students when they recruit, and they always talk about like, you know, what you put on social media, right? Like drinking, partying, stuff like that. You gotta clean that up because yeah, they would request access to your account, and then if you're downloading things illegally, they will know like software, cracking software, you know. So it's always good to come forward or clean it up now before you get the job. Okay, let's talk about solid state drive. You typically see, we talked about SSD and we saw that yesterday. You would see that you're using M1 or M2 and you're using PCI Express times 16. So this is how it works. If you see that if it's only PCI, so imagine that this is like one express lane, but this is times 16, so 16 express lane. So if I have many cars to send down the lanes, which is your data, if I have 16 lanes, I can send more cars down, right? Versus if I only have one lane and I need to send 20 cars, one car goes after the other, right? So your data path is, the wider it is, the better. So if you do PCI Express times 16, bless you, is better. If you have PCI Express times 8, which is half of this, that just means that it's 8 lanes, right? But it's not as fast as 16, which is double that, right? So incrementally, what we want is we want a connection, a port for our drive for performance is the more lanes you have, the better it is, right? So not all things are created equal, so make sure you check the specification and where it's plugged in. Okay. All right. Okay, so now let's talk about trim. And I touch a little bit of this. So I was amazed how many people that took my forensic class knows very little about hardware. Hardware is very important because if you understand how storage works, that's how you're gonna dig out information. So even when people delete things, right, it's kind of like your house, right? And they demolish the inside, but if there's remnants of room and things inside the house, you can actually piece a story together. And in forensic, a lot of the things are destroyed, right? You know that everything in your search engine can be retrievable. This is how people get arrested, right? For murder cases and things like that. I was looking at my LinkedIn feed, and some of my students that took digital forensic, they're working in the field now, and they're putting their job, their information. If FBI cases, police cases, you see a lot of that, and it comes back to hardware too. So trim in solid state drives is a way that it takes your deleted file and it reuses that location. Remember what I said, when I delete a file, it takes that space and it makes it available for the next file, right? We call that slack space. And the slack space, so all of your file has an address. So just think about it this way. I have data and I'm gonna put it in every single house on your street. House number 1, house number 2, house number 1 has file 1, house number 2 has file 15. Your system doesn't consecutively put, it just puts wherever it finds. So when you delete the file, it makes that space, that house become available for file 120. Okay? Now, when you do the trim, what that does is it takes that address in your solid state and it puts it back into a list that allows your system to say, oh, use this list to put files in it. So when you save files, that's what it does. When you delete files, that's what it does. So trim is just a feature that it deallocate the space for reuse, recycle your space. Yes.
You were talking about the information that we share online.
Right.
On Facebook.
Yeah, through social media, personal information.
Personally. So if you delete it, it's going to still be there.
Yes, that's correct. So is there a way that we can completely delete it? So all your data is backed up many times in social media, effectively, right? If they want to, they can go to your service provider and pull all the stuff that you deleted. So let's say that I went out, I went drinking with my friends, I posted a video, and then I realized that, oh yeah, I'm gonna apply for a job that's not gonna like that, so I delete the video, right? So when you apply for those jobs, they ask for your social media account, they log in as you to look, but they also hire investigator that might reach out to your service provider, Facebook, Instagram, whatnot, and ask their permission to look at your account 3 years back, 5 years back. A lot of the questions when they interview me as a reference is, does this person have abuse, like chemical, drugs, or like alcohol abuse kind of problem, right? So just be careful about that. But you're correct. Things deleted don't get deleted completely. You guys hear about the service that they have now? That you can pay companies to go and delete all your traces online? I'm gonna see how good it is. I'm gonna try them out because yeah, I don't like digital footprints too much because it's like, everybody can find who you are, everybody knows who you are, they even know where you live and all of those things. And it's kind of scary sometimes.
You're a good person.
Huh?
You're a good person.
But you don't know the intention of what they're doing with your information, right?
What I do is like for the Google search, you send the website information and let them know not to list the information. You ask the company and they take it out.
Yeah, you have to go through. So I'm not gonna have time to talk to all the service provider and they take a long time to respond to your email if they do, right? You have to make a request. I only reached out to a few because my account was breached and my data was leaked and so they responded. But sometimes even when you disable or delete the account, they don't necessarily delete it completely. So yeah, it's a process. Okay. But yeah, I understand. So the motherboard, we're gonna see that today on the next also exercise. So typically you would see ATX or MTX. So this is like what they call a form factor, the layout, right? So imagine your house has a layout. Maybe, there's a corridor to the living room, and then you have bedrooms, and you have bedrooms upstairs, and you have bathroom next to the bedroom. So the motherboard has a layout of where everything is. So the ATX, the processor is vertical, right? Adjacent to your RAM. It is parallel. Whereas some other form factor, it is perpendicular. The reason why that they changed the layout is some system, you're going to see that today, is compact in the case. And they want a certain way to circulate air, right? Your computer likes it cool. So, Nano is for the smaller system. Pico is like those tiny little desktop ones, right? But your typical full-size ATX is for the bigger tower, okay? Like the one that you're sitting next to, or sometime they would use an MATX. I'll bring in my build tomorrow and you can see that's an MATX. And then if you see Pico or Nano, those are a little bit more rare, but it's for like, those desktop that people have on their desk. That's like, you're going to see some of that today. That's like a small little box, right? And then the ITX and the Nano ITX. And refer to your notes. So this is what we're going to see. Remember what I said about perpendicular to your RAM, right? So when you buy a motherboard, this square location is where your processor is. Your RAM is going to go to these slots. There are actually 4 RAM slots. There's blue. I know it's hard to see in the picture. The black one, the blue, and the black. When you install RAM, because it's dual, you're going to need to put the blue and the blue together, right? So if I only have 2 sticks, one goes here and one goes here. Do not put 1 and 1 here, right? Because what it does, it writes across one to this one back and forth. Okay, so we want to make sure that we match up the color. What if I don't want the blue? So typically the practice is that you do the first one and then the color matching. Now, if you only have 2 slots, then you just plug it into 2 slots. But this one has 4. 1, 2, 3, 4. So you do the pair with the matching color. Okay, so that's the RAM. So I'm going to scroll down. So the first one, number 1, is up here, right? This is where you can connect all your external devices like USB. So that's what we call port cluster or port groups. Cluster is just like a group of ports. So I'm making you label this so that way you know what everything is when you look at the motherboard today. So that's this one, right, on the top. That's port cluster. Let me zoom out a little bit so I can make it maybe 150, 120. There we go. Is that a little better? Sort of. Can't see the font now, right? Too small. Maybe 150. Okay. So 1 is the top here. The 2, I know it's black, it's hard to see. It's like this little small slot that is connected. So typically people would add like an audio adapter, maybe some other type of adapter that they don't have on their system outside like video. I've seen some video ones too. Maybe like this motherboard doesn't have a wireless. Most motherboard now comes with Wi-Fi chip built in. And you would typically see, in the specification, but it would allow you to connect. So I can add a Wi-Fi adapter, and that's for number 2. But remember, this is 4 lanes, right? So it is a small connection like this big, like your thumb or half of your finger, your index finger. And it allows you to adapt another component like a wireless adapter. And then we talked about 16 lanes. So you typically would use this for storage, or a lot of people use it for your video adapter. And the PCI really is a way that we can add peripheral devices, like for systems to be connected for display, like your monitor, right? Or speakers to the sound, but a lot of the speakers now are either wireless or with USB. But 16 lanes is faster than 4 times, right? So Wi-Fi, we can put it on the 4, whereas video adapter, it needs to be faster. So 16, PCI 16. And then your CPU socket is here. So it has this little lever. So for processor, that for PC, there's only the 2 mainstream is AMD and Intel, right? I'm more of an AMD type of processor for build, only because I get more bang out of the buck, but it's definitely different design. And also the core build is different. So if you want to buy an AMD processor, you need to buy a motherboard for AMD. It doesn't work vice versa. If you want to buy an Intel processor, you buy a motherboard for Intel. It's like wheel and tire, right? We got to make sure it fits. This little metal lever is allowing you to secure, right? It is a way that we can dock the processor. We can sit it on top, and then if you pull the lever down, it's going to seat it flush, okay? But if you bend a pin on the processor, that processor is done. Okay, so be careful about how you seat the processor. And then on top of the processor, you would typically see fan, either liquid cooling or air cooling. I'm an air cool kind of person. I have friends that build all kinds of systems that are built into coffee table. I have friends that built a system that's suspended into the wall. I've seen people build system into fish tank. Did you know that mineral oil is okay? Like you look at it, it looks like a fish tank, but it's actually a computer, right? I'm sure you've seen YouTube video on that too. But it's really cool. So CPU socket is number 4. Your memory slots is 5, right? You have 4 slots on this one. This is an MSI, and this is the brand. Okay. And this is an ATX. So an ATX board would have appropriate power supply for it, because the form factor for the board is going to really tell you the size of the case you get. I don't get a nano case for a full-size ATX. It's kind of like you're going to buy sofa for the size of your living room, right? So the motherboard its form factor is going to determine, it's going to correlate with the case. So this, I'm going to buy power supply that is ATX, which fits my ATX case. Understand? So when you pick your motherboard, you need to pick your power supply and you need to pick your case. So for our project, I'm going to let you shop online for an ideal system. I'm going to give you a budget. And then you're going to go to like PC Part Picker, and you can pick and it helps you too, right? The system that you want to build.
So when you talk about the project, are we going to do it in this class or the following class?
This class.
You have 2
Yeah.
more days.
I know.
Okay.
There's a lot of time. But tomorrow we're gonna do a little bit of OS, right? And I will give you the project. It takes like 10 minutes, trust me. You can go add to cart. You can go to Amazon and even do that. You don't need to check out, right? Just calculate. Let's say you get a $4,000 budget. 4,000 build is good, right? I know I have friends that build system for like $10,000-$11,000, right? That's crazy. You have to have really nice system. In my opinion, a few $1,000s is gonna give you decent gaming system. Or you can just build a system for $1,000 or $500. There's plenty of ways. Okay. Then you have your USB port header, which is 7 here. This is very important for the connection because a lot of people, I have people that connecting the wrong pin to this, and when they plug in their USB in front of the case, it doesn't work, right? So your motherboard comes with like a sheet or layout, or their website would have information on how you connect the cable to your case, because your case needs to connect to the motherboard so that way when you plug in your USB, it reads, right? Because remember, your case in the front here, right? It needs to also connect. Because your motherboard doesn't come up all the way to the top of the case. It's the cable that connects to it. Understand? So, and typically you see this cable is blue for the 3.0 and black for the 2. And then front panel cable header. Also, if your front panel cables are not connected properly, like the layout that you should refer to for the motherboard, your power button doesn't work, right? Stuff like that. So I've had like many former students when they build, they would like email me, they're like, I don't know why I can't turn my computer on. I checked and everything is connected properly. And I was like, yeah, check your header cable because the case is connecting to the motherboard in the wrong way. So when you press the power, it doesn't send the power signal to the motherboard, so it doesn't turn on, right? That's like a very common problem. Okay. So front facing SATA ports, this is for drive for number 8, which is here. And it's kind of black, it's hard to see. I should use a different picture or make it lighter. But the L-shaped SATA cable would connect. This is for your drives. Okay. And the drive would go to the bay of your case panel. And then for 10, is over here. So 10 is your front panel cable header. Like I said, that's your power cable and different things. So power buttons would work. And then if you have, most of them would have fan on the case. So how many fan is good for? So if I have 2 fans, right, one in the back and one on the side, that's the typical case. That's your standard, right? In my opinion, I like to also, I'm air cooled, so that means that I like to use fans. And I would add a couple more fans. So it would have space for you to add like maybe another fan on the side or on the bottom. So for the ATX, it's gonna circulate air in and it's gonna hit the processor first, right? And then it's gonna go to RAM. So that's how they design the cases. It's gonna bring the cool air into the processor. And then the next part that's important is it's gonna, before the air exit, it's gonna hit the RAM and it's gonna exit from the bottom. So when they build the case, you're gonna see a top fan and a side fan. Okay. And then the last one, which is like your clock battery, that's a CMOS battery. Now, some new boards don't have this. If you buy a gaming motherboard, they're gonna have like covers and things that has logo and colors and stuff, right? It might cover some of this. But it's really for look, okay, in my opinion. This one doesn't have like an M2 for solid state, but on the new one, you should have it instead of SATA. And that typically is closer to the South Bridge. So this chip right here and this chip up here there's 2 functionality. You have a South Bridge, they normally put a brain cover on it, and a North Bridge. So the North Bridge chip is really geared to help with the processor and the RAM. And then the South Bridge chip, the second chip on the board, is really for the components like your drive, your USB, and other things. Okay. Okay, 20. So what is, let me zoom back out or in. What is the difference between your PCI and your PCI Express bus? So when I say a bus, that's like a road, right? A path. PCX is fast. It's 64 lanes, so 64 bits. It's much faster than your regular PCI. So imagine if you can only do like a few bits, right? Like I can send a few cars down one road, or I can send 64 cars down 64 lanes at once, right? So your data is transferred quicker. So a bus, just like what we talk about, like riding the bus, is I can transfer from one location to the next, right? I can transfer at a faster rate. Okay, SATA 3. I haven't checked. Maybe they have 4 and 5 now, but SATA 3 transfer at 6 gigabit per second. So this is for hard drive, right? So your typical hard drive uses serial ATA. So that means that if I have a very large file, right? So let's take like a movie. A movie can be what? 2 gigs, right? So if I do 6 gigabit per second, and if my movie is 2 gigabyte, right? How fast is my movie being transferred? Fraction of a second, correct? But that's only internal system. I'm not talking about through the network, right? So if I edit the movie, if I need to transfer it from my drive, right? Maybe, save it as a file and then move it from one drive to the next, that's the transfer rate. Okay. But when you go through a network, that's a different rate. So if you use Ethernet cable, like what we talked about, is faster than if you use it wireless. Okay. So in your Windows system, your PC, instead of just using only BIOS, which is basic input-output setup, to configure your installed components, you can use what's called UEFI. So whenever that your computer breaks, this is what you typically do to kind of check and test your device. So the rule of thumb, I always start with a physical connection check. So if the computer doesn't turn on, check if the power is connected, the cable power, right? Press the button, right? And then I would start with the physical check to make sure that my power button is connected to the motherboard and so on, right? So you would look at the physical component. Then I would then go into a logical check, which is mean that looking at configuration. If I cannot turn on my computer, I cannot go into UEFI for sure. Okay. So you have to figure out like, why is your computer not turning on? Is it not having power connected? If your power is connected, and then you're going to dissect each component, starting with the case, the motherboard, and moving to the drive and so on, things that are attached to the motherboard. So through the process of elimination, then you're going to identify. So how can I know if a drive is bad or a motherboard is bad? By using a good known device. So if I don't have a second motherboard to plug it in, I might need to take my motherboard and use another system to test it, plug it into another PC, right? That is running, that can run. So that's how we test. And that's typically like an A+ question. So check the actual physical connection of your components. You can also test your device. You can test it with like, electrical tester that also works too, but not everybody has that. So the way I test my device, I take the drive, I plug it into another PC. If it reads, the drive is good. I take the motherboard, plug it into another PC. I know the process is you have to take everything out and plug it in. If it works, it turns on, then it's good, right? So through that, you would go through, and sometime when you fix these things, one broken thing can take you hours, or one broken thing can take you minutes. It depends. So as you build the experience, you're gonna test the device a little quicker, and you can check. So check for error, check for setup boot. So tomorrow, if we have time, you're gonna make a boot disk too. I'll teach you how to do that. Okay. Maybe I have small USB in my office. I gotta swing by there tonight. Okay, so let's talk about CPU, stands for Central Processing Unit, right? That's different than GPU, which is Graphic Processing Unit. But it is really made to process, right? One process graphic and the other process task. So when you buy CPU, like I said, Intel's different than AMD because of the way it's installed, right? Physically, they are different. The design and the instructions are different. Everything is different. It's kind of like a Ford and a Toyota, two different things, right? I refer to cars a lot because everybody knows cars, right? All right. The socket on the motherboard, where it's installed, right? A lot of the processor now has graphic features built in. Also the buffer size, the cache size. So cache, remember what I said, the laundry basket? The bigger the laundry basket, the more clothes I can temporarily store. And I just have to haul that into my closet and dump it, right? Stack it up. But if you have a very small basket, your tasks become more tedious. You have to put a few things in, carry it to the, So the cache size is your internal storage to the processor. The bigger this is, and typically these are in megabytes, the better it is. Okay, this is for buffer, temporary storage. Okay. And the old school is the 32-bit. Right now, everything is 64-bit. So if you have a very old computer like Windows 7 or pre-Windows 7, which nobody used anymore because Microsoft doesn't support that anymore. They are moving directly into 11, 10, the old 10 is not supported. I'm surprised that they came out with 11. They announced that 10 will be the last one, but 11 is like 10.x. So 64-bit. We want 64-bit apps. But I still see some apps around that is 32. So if your processor is 64-bit, it's backward compatible to understand 32-bit because it's larger. Okay. So the difference is between mounting the heatsink. So when you look at the heatsink, I'm gonna come back to the top. I'm gonna show you what heatsink kind of look like, but on a So these right here, this is for the adapter, but you typically see heatsink like that. They're like these little fins that are on top of the chip. So when you actually physically remove that, which you shouldn't, you would see like the black square chips, right? So what chipset, but on the processor, you would have an actual fan with a heatsink, a component that you would sit on top, so that way it can cool it, right? But if you're using liquid cool, it would be a separate component, but it's still doing the same thing. So your goal is to draw as much heat from it as possible. That's very important. So how good is cool? What do you think? How good is cool? Is it 70 degrees? Is it 80 degrees? Is it 32 degrees? Is it 100 degrees? So when is a computer is too hot? And what happens when it's too hot? What do you think?
Shuts off.
It shuts off, right? It powers off or it try to reboot. Okay? Because if your fan is failing, if it's too hot. But what do you think? Some of you will be ending up in server rooms, right? When you go in there, you need to wear a jacket. It's kind of like a freezer section. So Your computer likes it around 60 something degrees. Ideal. If you're gaming a lot, you need to really keep your system cool that way. Extra fans or extra cooling component. If you're using a laptop to game, maybe a cooling pad or making sure that your fan is working. And when it's doing that, you hear the fan, right? Sometimes it's very noisy. If it's like the bearing motor is going on it or it's just a bad fan. I bought a gaming computer that's kind of like China brand, and I got it for really cheap with really good spec. For like $1,000, and it kind of blew my mind because that same spec in other system it would be a couple grand. And when you turn it on, and I sometimes I use it for virtual machine, and it's just squealing, you know. So the fan bearing is not very good. We're gonna do break pretty soon. Okay. So if it's above, like, I want to say when it gets to close to high 70s, you're going to start seeing sign, right? That it's too hot, or when it gets to the 80s. The processor now, it has a guard so that way it doesn't catch on fire. So it will do a safety. So they shut it down. But some processor will also send you a message that it's too hot. And then, on the higher end GPU, it also let you do the temperature control on it too if you're gaming.
I was gonna say or ask because I have liquid cooling, but in most cases, like if you're fixing computers, so it's not gonna have that. I mean, they might be like
Yeah,
Yes.
like these computers have it if you're looking at the Alienware panel, right? A lot of the computer now, but your regular workstation might not
Yeah, that's
have
right.
it. And sometimes that feature don't necessarily gets turned on because that's just additional RAM and things that you need. But anyway, yeah, so but when you look at the configuration, the motherboard actually has a temperature gauge. It will tell you if you go to UEFI or if you go to BIOS. Yeah. Yeah, I had worked on a couple computers that the fans kind of stopped working or the connection was bad, right? And it keeps rebooting or it shuts down. So yeah, that's just a safety feature. Sometimes you replace the fan, sometimes it's a processor issue, so or a heat sink issue. Yeah, I hate it when I have to remove the heat sink to replace a heat sink. I don't mind. I might as well just replace the processor because it's such a process. So a heat sink sits on top of the processor, right? And make sure that you get the right heat sink for the right processor. So if you buy an AMD processor, you get an AMD heat sink, a fan, and a heat sink. So heat sinks are like silver metal fingers that draws the heat out. Okay? So you have vertical and horizontal heat sink. The vertical heat sink, it sends the air up from the processor. It pulls it up. Whereas the horizontal mounted heat sink, which is typical in liquid cooling, it draws it to the side, and then the fan cases will take that hot air and take it out and let it exit. Where if you see the top mounting, that's typically a vertical, it's gonna pull it up and it's gonna send it to the top fan of your case. If you look at your Alienware, there's a fan on the top too, along with the side, right? So it's really designed for multi-purpose. And there's a thing called active heat sink and passive heat sink. So an active heat sink would have a fan. You would see a fan spinning. Whereas a passive heat sink that you saw at the first picture on the video adapter, that's a passive heat sink. It doesn't have a fan. It's just a little metal, a metal piece that goes on the chip. And on the motherboard, you see little heat sink here and there. And that helps the chip or the chipset cool. So the motherboard is considered a chipset because it has a group of chips for different things, for sound, for wireless, right? For RAM, for drive control, a lot of different things. So before you put a heat sink on your processor, when you take it out today, you're gonna see there's like a little glue-like case, and they dry up, right? That's called right? So this is the adhesive component that goes into the CPU. So if you ever build a computer, you can buy a tube. You probably don't use it even if you build 10 computer. You only need like the pea size. But don't let it ooze all over your processor because when it gets to your motherboard, it damaged the board. So what I typically do is just like toothpaste, right? You take a little bit, you dab it in the middle on top of your processor. And I would take like a piece of business card or some kind of hard paper and I scrape it evenly. Arctic Silver is one of the brand, but Amazon has a lot of thermal paste that you can use. That's good. Okay. So the characteristic of a good graphic adapter, we talked about this today. Anybody bought a good graphic card lately?
Not lately.
I forgot to bring in my graphics card with me.
Yeah, so NVIDIA separated from AMD a while back, right? You know that they're cousins, right?
Yeah.
The CEOs. I'm sure you probably read somewhere. But yeah, it's true. Okay, if you don't believe me, find out. They're the executives of the company, the owners of the company are related, right? So NVIDIA separated now, and AMD has their own. A good graphic card should have good processor speed, so check the hertz on that. Good storage, the cache size. We talked about that with the processor. Very similar to the processor, and also additional storage. So it'll tell you the size, the capacity on that. Ports and fan. Okay, I'm just curious, so let's ask Google or AI, Gemini. So we wanted to see what AI would give us, right? So NVIDIA GeForce RTX 5090, which is, yeah, so it has 32 gig of storage, right? It uses GDDR7. Remember we talked. So similarly, it has RAM or memory built in into the adapter. You can also use others, right? Like RTX 4090, which is a little bit less in price. So, or you can go a model older. Okay. Now, like I said, before they used to produce graphic adapter together, but now they separate it. So you have AMD Radeon, and this is the RX 970. So let's see. So that's what it looks like. You got fans, right, on top of your GPU. And then compared to the look of this, similar, right? That's what you see. So it needs to draw the heat from that too. But probably, as you can see, the investment in this is probably a third of your gaming computer, or half. I remember it used to be under $1,000 for a good adapter not too long ago, right? A lot of it is that the price for storage has gone up. The demand for GPU has gone up because of AI. So a lot of people buy this also to mine Bitcoin, or other things. So, you don't always use it. So you can use GPU for AI, for, also like do other things with it.
Maybe it doesn't even advertise the game.
Right. So we can go a little older, which is a couple years older for the 5060 or a few models. Look at the price drop, right? So if you don't need to have the most latest, you can still have a good spec for adapter for your game. And then you can go with like less of a brand. So NVIDIA is really, you want to get it for the brand and you want the latest version. So it's going to be more demanded. So it's going
How
to
do you
be.
know if what you're buying is?
Like we said, we want the processing speed, the storage, right? And reviews is gonna speak a lot to it too, right? The consumer review is gonna give you like the direction. But so AI asked me if I wanted 4K gaming VR, and so that way it can give me some suggestion, right? But AI suggestion is really gonna come down to also what Google used for advertisement as well, right? Some of the marketing strategies is gonna go into this, so you can't believe it 100%. You can only get some suggestion, and then you can determine based on your research as well. So I really think that you still gonna decide on what's best for you. Okay. All right. So when you install after you install your adapter physically onto the motherboard, you need to install your driver. It's very important that you do that, right? So how do I do that? It usually suggests it to me, but if you don't, your operating system is going to pull the file that it has and it's going to substitute it with that. Microsoft tends to do that. It will put in the generic driver. So drivers are like software instruction for your hardware devices to function. It's kind of like, you know how now you have the self-driving car, you can put in the direction for the car to go from point A to point B. So the instruction for the adapter is to display the best, right, that it can with its specification. So if you have a poor driver or generic driver, it's not going to be optimal. Whereas if you buy an NVIDIA, you need to get the driver from NVIDIA. That's going to give you all the features, all the things that you need for gaming purposes. Because if you're going to invest $1,000 in your adapter, you should maximize that $1,000. I think if I build a gaming system now, I will not go above $700 for an adapter. I think a good adapter is $600-700, but also because I'm not gaming and I use adapter for other things, like for LLM or other things, but it's not important to me to get all the graphics features. But for other people, that might be very important. Sometimes if you get a pre-built system with the adapter that's cheaper, probably take that. I had a student that asked me that, should I just buy a pre-built system that already has that? Because sometimes they sell you a package that has everything that's a little cheaper. Okay. All right. So plug and play USB wireless adapter. P&P stands for plug and play. Your USB is plug and play. You plug it in and it's ready to use, right? But if you have a wireless adapter, and I use this for my ethical hacking class, I'm going to show you that with them. So it's easy. Okay. So they come in like this, right? It's like $15. You plug it into your USB-A, or now they come in C. It has an antenna. You want one that has omni antenna. That means that it's 360 antenna, not directional antenna. And they die out sometimes. You have to install the driver for it. So you go to the vendor website, and you can download the driver for your operating system. So if you run in Linux, you need to get a driver for Linux OS. If you're running, you plug this in and Apple doesn't tell you what it is, you need to download the driver from the website. But typically, it's going to try to put the driver, so that way you can use your adapter appropriately. So the majority of my lab for wireless attack is to spend time to configure the driver for this, because Linux driver sometimes is tedious.
And what does it do?
If your computer doesn't have wireless, it becomes a wireless system. Yeah. So you can connect to the wireless network. Now, you might see one that has a built-in antenna. So it comes like a USB drive, right? And it tells you that it has a built-in antenna. But if you are going to be an ethical hacker, the more antenna, the better, because it goes the distance. The built-in antenna, you guys saw the wireless adapter on the laptop yesterday. It has a little white wire. That's the antenna. But if you have but your antenna, the way it's designed, sometimes you see routers that have like 6 antenna. It spans a little bit better, right? So you guys want to see some cool ethical hacking stuff? Maybe I have time to show it to you for another class, but let's knock this out first. Okay, let's look at your power supply. This is called a molex, right? When you look at this also called a Berg connector. This is typically what you see with like fans or things that needs power, or sometimes also motherboard. Right, on the motherboard, the ATX, it has like a 4-pin connection. And I wanted to label or color code and show you the color code, the standard color code for power supply. That's really important, because if you're not getting electrical signal, you need to know like which wire caused the problem. Red is typically always positive in the electrical world, as you know. Black or brown, sometimes gray, is typically ground, right? Ground is 0. And so what you see is GND is for ground. That's typically a black, brown, or dark gray color. And then when you see a yellow, that's a higher voltage. So some of your devices require 12 volts. Hard drive, because of mechanical movement, it requires 12 volt. Things that have motors base requires 12 volts. Other devices only require 5 volts. And then your lights, like LED in the case, requires less volts, like 3 volts. Okay.
But isn't number 3 orange?
Yeah.
You put yellow.
No, 3 is yellow. The one above it is 4, it's red. This one had red, yellow, black, or black brown.
I gotta get new glasses like this.
No, sometimes it's hard to see also a dark picture. Okay? I think we talked about this before. Your SATA 3 or your eSATA, it's 6 gigabit per second. That's the speed. So how many drive can you connect to one cable? One cable, one drive for SATA. Just like the M2, right? One slot, one solid state drive. Okay. Unlike SCSI, you cannot like daisy it out. It doesn't work that way. So if you have 2 drives, 2 cable, two connection to the motherboard. Okay, so you can only use 1 cable for a single drive. I mean, it's just logical, right? Common sense. There's no 2 connector on a cable, so you only connect 1. But, you know, for exam, they ask silly questions sometimes, and you're like, wait, aren't you trying to trick me? So just be your intuition, first guess, right? Common sense, just be logical about your answer. Okay, the transfer rate for serial ATA-E or SATA version 3.2, which is the next version, I think they labeled that for, which is double or actually almost triple the speed, so 16 gigabit per second. Much faster. So why is this important? If you do buy hard drive to replace for an old computer, look at the serial ATA for the motherboard, right? If it's like 3, look at the drive that you need to use. But if you use the old standard 3, it's 6 gig. But if you use SATA E or SATA 3X or 4, that's going to be 16. Okay. So how do you configure this? On the drive of the PC, so you guys know what hot swapping means? So in data center, we don't shut down computers. Servers don't go down, right? They rarely go down. Sometimes they go down because they crash or they're being attacked, or we have to really physically replace RAM or something to it. So there's like 1% chance that it goes down. Because if it goes down, you have to put another backup server to run. So that means that if the drive is full, I cannot shut the server down because other people's are logging in. Imagine Amazon. If you shut down the server for a few minutes, how many customers are gonna lose, right?
Yeah.
So what you want is at the data center, we do a hot swap drive. That means that the system is running and you pull in the drive, right? You're like, wait, you said not to turn on the power, right? But these systems are designed for you to safely remove the drive, and we call that hot swap. Okay? So if you want the drive to be hot swap, maybe it's a server, then you need to make sure that you configure this mode in the system setting. Otherwise, it doesn't let you. And also the drive itself is that type of drive. You cannot just make any drive into hot swap. Okay. Yeah, don't touch electrical signal when it's on, bare hands, right? So it has to be specific system to do that. I watched a documentary about Facebook data center. This is a while ago. They expanded, right? You know that there's one in New Jersey and there's one in Mountain View for California, and they have different parts of the United States that house their data. They also span across the world. And in one of the data center that they were building, the technician has less than 6 minutes so he gets a notification that drive is full. He needs to change it. So he pushes cart over, right, across the rows of server, identify the server, pull the drive, and he has 6 minutes to do that at a data center. Okay. If you ever go to Los Angeles and you drive on Wilshire Drive, right, you're going to come across this black building. And in front of the building, the address is like 1011. It's binary, right? They're kind of. And inside that building, many floors house data center server racks, okay? But you also see remote locations when you drive to Vegas and other things. They house data for government, military, stuff like that. So, okay. I know it goes on forever. 35. Besides printer, monitor, we're going to identify 3 types of peripheral devices. So VR headsets, barcode scanner. You see this at the store a lot. Speakers can be also peripheral devices. So that means that devices can be attached to your computer. Microphone, microphone, bless you. Mouse, keyboard. So I/O devices are peripheral devices, right? Projector, output. Keyboard input, mouse input. Optical drive. I can have an external CD player if I don't have one on the system. So
Webcam.
yeah, webcam, that's right. There's lots of things that we use now that's considered peripheral devices. So when they tell you peripheral devices, what do you think about? Devices for input and devices for output, or both, right? Like a webcam. It can record you, but it can, for input. So what is the purpose of KVM switch? I have one up here. It's actually installed. So let's say that you work at the warehouses. You see a lot of this. You can have a mouse, a keyboard that can be shared with multiple computers. They do this so that way you don't have separate workstations. You might have monitors, right, to show like their different system, different tower, but you can share mouse and keyboards and I/O devices through KVM. Okay. So basically it's a box that you can plug in and it shares that signal across multiple computer. Okay, that means it's a switch. I know we're gonna need a break pretty soon. So I'm gonna try to hold on 1 second, let me check. There's 42 questions. A plus is just so much information. All right, let's knock these out. So power supply, we already know that computer uses, right? We need to go from AC to DC, okay, and vice versa. So convert power from high voltage, which is your alternating current. You guys know that your household current is inconsistent, right? Don't plug your computer into the direct outlet. You might search your computer. That goes for laptop, Apple PC, tablets, etc. Use a surge protector. Surge protectors are really cheap, right? But when you buy a surge protector, you need to look at the joules. The higher the joules rating on the surge protector, the more it protects. And also some of them, they would have a warranty. So if your computer fries and your computer costs $7,000, they might have insurance to pay for that, right? So if you pay for $20 for the surge protector, they have warranty for that. So surge protector regulates the currents that goes to your system when you charge it. It's very important that you do that, and you should do that for your phone as well. Even if you use like USB charging. I see people just plug things in directly in my household. Every outlet has a surge protector. I'm just crazy about that, right? Because you don't know. You get surges and then, there goes your system. There's nothing you can do about that.
So Professor, what do you do when you travel? You take your surge protector with you?
I have one actually, and I have some in this room too. Yeah. So see, this one I brought, it's right here because they didn't have one for my laptop, so I plug it in. They told me I'm not supposed to daisy chain, like that means you just connect surge protector to surge protector. But what can I do, right? I either connect it there or connect it here. So, but did you know that at your desk, it is a form of surge protector, right? So it's built in. Okay. So on your power supplies, it's gonna have a switch. One is gonna be 115 to 120 volts, and the other is 220 to 240 volts. When you buy your power supply, it should be for North America, which is the lower one. Okay. Don't switch it over to the higher one. That's for other part of the world like Europe and Asia. So if you build a computer in Europe and Asia, this is the voltage range because it's a different type of electrical grid they have. Compared to us, and as you know, if you travel, you have to use like a right charger, right? For North America, Canada, United States, Mexico, etc., right? You are going to use the lower one, which is the 115 or the 110 to 120. Okay, so don't switch them. Okay, so I give you the picture. This is for your motherboard connection. Sometimes you see the long one. This is for mainly for motherboard power, and then the secondary, the second part of the motherboard. So it usually you're gonna have this one and one of these. So this one is for a 12 volt. So your hard drive requires a 12 volt. There are other components. If you read, your processor requires about roughly 80 to 90 volts. Okay. Depending on the processor, sometime over. So the more power, the consumption. So altogether, our power supply needs to be rated for the wattage to all your components combined, but you should have a little extra. I've had people build system where it's like just a little bit over, and then when they add another component, it fails, right? Or you have to replace the power supply. Okay. So you already see this picture. You can go through and you can label it, but So one is your 12 volt secondary ATX. This one is UAX secondary for 2. ATX primary, this is a 20 pin. You can count it up. And this one is a little longer. It is a 22 pin.
Sorry, it's a little off topic, but will A plus have at least
Yes.
acronyms like
No, they ask you pin size.
size?
Yeah, or ATX.
24 pin, 22 pin or 24 pin?
Oh, 24 pin, sorry. I meant 12 volts, 2.2 primary.
So
But so like these, sometimes you can also reduce them, right? They have options where you can separate the 2 pins and use 4 pins, and you can only use 20. So they are interchangeable for ATX. But remember, ATX power supply for ATX board for ATX case, right? They all go together, one set. Okay. This is long, you don't have to put verbatim, but what I want you to know is that when you replace the power supply, it must be the same type. The equal or higher wattage, the same form factor, like ATX, ITX, right? So your case is an ATX, you need to get an ATX power supply. If you have an ATX power supply, buy another ATX power supply to replace. Don't try to be creative. If you buy a different power supply, then you have to buy a different case, another motherboard, build another computer, right? So because the form factor really relates to size, shape, right? And switch location, it's designed for the case. Everything fits together. And also it supports specific, so when you select a power supply, look at like your CPU power. It tells that on the website or on the CPU box or manual. Video card, motherboard, and drives, things that require power. You add all of those up, and you should have a sum by a power supply that's gonna be more than that sum in power. Okay, but this really means that your 12 volts and your connector really needs to support the components that you have on your computer. Ultimately, that's what it is. Okay. When I taught in other classes, especially college and desert, I need to make them find out like how much power is your processor, how much power is your RAM, how much power. So all motherboards, right? RAM is powered through the motherboard. How much power is the motherboard? When you add all that up, you are going to get a wattage for your power supply, because I have students that tell me, oh, I bought a 900 watts power supply and that's like $500, for example. Excessive, right? But that if you don't have the components, you can go with like a 700 watts or 800 watts, and that's plenty. But if you build a computer that requires 1,000 watt, which is a lot, right? Then you need 1,000 watts. I actually have 1,000 watt non-rated power supply. Almost scared to put it into a case because it wasn't rated. But I got it when it first 1,000 watt just came out, right? So, but you see a lot of that now. Case, the company that makes the case also make power supply. Yes, you have question?
yeah, for the ATX 12B 2.2, it says on D it says the 4 pin, but then or above it has 24 pins. So is there different pins for?
Yeah, so the 4 pin, so you can separate the 4 pin to make it a 20, you understand?
Yeah.
So the main power requires a 20. So if it's a total 24, you can actually separate the 4 pin, and they're just hanging out. So a good installer, they would wrap it so that way it's just not like
just
hanging out, right? But if you have a motherboard that requires all 24 pin, then you can use all the pins. So they let you do it that way. So you can have, so that 4 pins really gonna give you a 12 volts. Compared to the entire power, that's a lot more volts, right? Combined. But you can also use like an 8-pin power connector that's gonna also give you 12 volts. Yeah, there's like different option, but what we want is, like I said, right? How do you know if the wattage is enough? You just sum everything up, your main components, processor, memory, adapter, like video adapter, drives, or anything that's also bus, USB based, like if I connect like, I don't know, speakers and stuff, which is very minimal in power. It powers through your computer. When you charge your phone, it powers that to your computer. It needs, so if your sum is equivalent to 70% of your power supply wattage, then you're good, right? But if you're higher in range, right, consider going a little bit higher in the wattage. But excessive is I think it's kind of wasteful, but because you're gonna pay a lot more for a higher wattage supply. Most of your workstation desktop, if you look at Lenovo and stuff, they're gonna give you like 400, 500 watts. When you open these up, it's gonna be like 200, 300 watts because the older computers, motherboard and devices, because they're low in capacity, they don't require a lot of power. Yeah, I fixed a lot of Dells, and when I opened it, it was like 250 watts. I was like, wow, my processor alone consumed more than like close to half of this, right? Your typical Intel processor is gonna be like 100 plus watts. So knowing a little bit of electrical is good, right? Especially when you're troubleshooting integrated circuits. But you don't have to be like well versed in it. Just positive, negative ground. Yeah, when I teach embedded system or microcontroller, we work with breadboards and stuff. Those are pretty fun too. So you can learn like Raspberry Pi, Arduino, stuff like that. Just kind of understand a little bit about like how computing work with electrical system or components.
Raspberry Pis is like those little computers.
Yeah.
Yes, okay.
Pi can be cool. I think the Pi 5, it has quad core. And it's a different type of processor, different architecture than your Intel and AMD, but you know, it still does the same thing. And it's best to run embedded Linux with it, but you can put like I wouldn't put Windows on
Yeah,
it
no.
because Windows hog a lot of resources.
I haven't heard of it. I'll look it up.
Yeah, Pi is you can build all kinds of projects with Pi. Very, very fun. I last summer I taught a course in Pi and a course in Arduino. And then we made stuff with it like automatic trash can out of the cardboard box. They had fun with that. So we work with motors and stuff. Yeah. I like to tinker with computing related gadgets.
And where do you find the time?
I used to have a lot of time to build projects. Now I don't anymore. I have a lot of things that I wanted to do. One of the certification that I have been looking at is it's called Red Team AI. It's ethical hacking AI. Like, you know, you probably hear that AI is used for hacking, but to breach it, like to be able to, you know how when you have the prompt, you can inject things into it. You can type a bunch of script into it and see what. I broke an app this morning. Somebody gave me an app to test and an AI app. I started like just 5 minutes in, it's already spitting out code. And I'm like, broken. But yeah, so that's kind of what I wanted to do now. I have a couple of things that I wanted to work on for next semester, like to look at some, I saw some stuff on using AI agents for forensic. That's pretty cool. Forensic OSINT came out with some new versions, so new tools for the class. So I want to update their labs, stuff like that. So it's more for like work, but it's also fun. Okay, so before you go to break, I'm going to show you some cool stuff, but this can be for the C class. So there's a site. I already talked about the flipper, correct? You guys heard about the flipper? Not flipped.
Oh yeah.
So Flipper Zero, this is $200. I just got this the other day. I have adapters that I can use to tweak it. But you know, so this like it comes with you can make this with Raspberry Pi, but it's requiring a little bit more work. So it sends it detects, right, signal, and you can attach different things to it. This is also an embedded system, but look at like it has a transceiver that's 1 gigahertz. That's it basically transmit signal at that rate, right? And so you can make it into like a car remote for Tesla. So fun. All right. Another thing that you can check out if you're interested in cybersecurity or you want to become an ethical hacker. I have some of the gadgets and I can bring it and show it to the
What's-
third class.
what's the difference?
So remember what I talk about antennas? Antennas are cool. So this is used to test your Wi-Fi. It looks like your wireless router, but we can do things like evil twin attack with it. So I can mimic your AP in my car using my laptop and my power bank, and get your user to access it. People get paid to do this, by the way, right? So they sell stuff like this, but look, the basic. So I have a smaller version, but it's $850, right? And so they have so many, so many cool things that you can play with. So this is not your normal USB. I have a rubber ducky and it has a specialized chip on this. So when you plug this in, it has a capability of a Trojan to keylog. That means that whatever you type, it saves and then I can instruct it to send it to me and I can get your password, right? So we can do USB drop to get your employees to see if they pick it up and plug it in because you're not supposed to do that. Yes. Yeah. This is fairly new, right? And so they manufacture specific chips. So if you look at other comparable components on Amazon, it's not the same. Heck, I've been in the business for a long time. I have a Wi-Fi Pineapple, an older version. It used to only be $100, but look at it now, right? So this is like it has an embedded system, kind of like Raspberry Pi inside, but you have USB connection for power. And what it does is it has tools that you can use to get people to access you. So if I sit around here, right, I can mimic an AP, like your school AP, and I can get other people because your access point is like, here I am, connect to me, right? So I'm gonna be like, here I am too, connect to me, right? And then so someone is looking on their phone, like, oh hey, there's a public Wi-Fi, let's connect to it, right? And then through that, I can scan you, and if you're logging into your bank, I can, if you're using things that are not secure, I can get your password. I can drop malware. So more to come if you want to take my class. So that's just like, a pitch to it, but it's cool. You can find some information. They have tutorials for you to use. They also write books. But gadgets are fun. Okay.
Winning me over the ethical hack.
Yeah, I don't use all of this in ethical hacking. I wish they can buy me this, but I shared this with the student. I did a demo for an apprenticeship session with Rubber Ducky. And then, the companies that brought the conference, they do conference every year for Security Month, which is like October, November. They brought in FBI because I asked about deepfake. And then I have labs on deepfake now, which use AI to be able to generate. You guys know about deepfake. People make fake videos from AI. That's called deepfake. But they can take your face and lay it to their face, and they can FaceTime you and do scam, right? That's true crime and deepfake. But yeah, and how to detect it. So that's kind of growing right now in that area. Okay, let's take a little break and then we'll come back and we'll work on the lab and then we'll call it a night.
Can you put it on the last slide? Thank you.
It's been